of you want to do on your own as well while I draw the other one. Okay, so that equation is y equals negative a half, bracket x minus 4 squared plus 2. So guys, if you are looking at this equation, right, obviously in a test or exam, they're not going to tell you this is turning point form. You need to be able to look at that equation and recognize that it looks like this. Right, remember this is turning point form as we wrote it down in class. So you need to be able to see the a value is negative a half in this case. Right, a is always the number in front of the bracket squared. Then we do have a bracket with two terms and the x obviously in that bracket, and it's squared. And then we have a q value that comes after that bracket. Okay, so you need to be able to recognize that that is turning point form. And in turning point form, guys, remember that the turning point is going to be P and Q. I'm just reminding you because it's been a while since we spoke about this. The turning point is PQ. In the bracket, we have x minus P, but the x coordinate of the turning point is positive P. So if we're looking at this equation that's given here, guys, the turning point in the bracket, we have x minus 4. X minus P and x minus 4. What is my P value? 4. Good. Remember the sign is always different in the bracket, in the actual equation, and then in the coordinates of the turning point. So if it's x minus 4, your turning point has an x value of positive 4. All right, the Q value, that sign is always the same, guys. So what is the Q value for this graph? 2. So that is the turning point. Okay, the turning point is the point 4 and 2. Guys, if it was x plus 4 in the brackets, the turning point would have a negative 4. Okay, the sign is always opposite. This, unfortunately, is not enough information to draw the whole graph. We do still need our y-intercept and our x-intercept, all right? So just like yesterday, y-intercept, or maybe not just like yesterday, because for this one, you can't actually read off the y-intercept coordinates just by looking at the graph. You actually have to go through the whole process of making x equal to 0. And then you're going to work it out. Okay, so guys, in a test or exam, you don't have to write the actual substitution line down. I am going to write it down, just so that if you look back at this, you know where the answer came from. But you're going to keep your whole equation, and you are just going to replace x with a 0. All right, so in that bracket there, we have 0 minus 4, which is negative 4. But we are then squaring it, which is 16. Yes? What's negative a half times 16? Negative 8 plus 2 is negative 6. You can obviously also just type that into the calculator. That's absolutely fine. So the y-intercept, guys, is the point 0, negative 6. We also need to find our x-intercepts. And we do that by making y equal to 0. So in the equation, we are going to make the whole equation as it is equal to 0 instead of y. And now we're going to have to solve for x. Now guys, this is a little bit different from yesterday's example. Yesterday's example was already a trinomial, I'm assuming, right? I don't know which examples she did with you guys, but it was already a trinomial, so you could just go straight into factorizing and solving. This, as it stands, is not a trinomial. You can multiply the brackets out, right? But I don't like that negative a half there in front. That's complicating things a little bit. So I just want to show you guys another way of solving for x here. You don't have to do it in this way. I just want you to have an example of it. I'm actually going to move that plus 2 over to the other side. All right, now bear with me. You'll see now what's going to end up happening. So I'm moving that plus 2 over. I'm making it negative 2, obviously. And now I'm going to divide by this negative a half. What is negative 2 divided by negative a half? Do you guys know? A negative divided by a negative, firstly, is a positive. And what is 2 divided by a half? 4, hey? There are 4 halves in 2, so that is positive 4. Now, guys, from here, you can obviously multiply the brackets out, get everything on the one side and factorize. But you can also take that square over. What is the opposite of squaring something? Square rooting. What must we always remember if we're taking a square over? What must we also add on the other side? Plus or minus. What's the square root of 4? 2. So again, I'm just showing you a different way of solving for x in this equation. Okay, you can also multiply the brackets out and factorize if that's what you want to do. That will also get you the correct answer. I'm going to be with you now, Ross. What is the opposite of subtracting 4? Adding 4. So on the other side, I'm going to say 4 plus or minus 2. What does that mean? 4 plus 2 or 4 minus 2, right? That's what the plus minus means in maths. We're going to say x is equal to 4 plus 2, which is 6. You don't have to write that down, but maybe just for this example, let's write it down. Or 4 minus 2, which is 2. So that will give us our 2 answers. You have to get 2 answers from this, guys. And if you leave out that plus minus, you're only going to get 1 answer, right? Which is wrong. Ross, what was your question?
I don't know. That's what I'm on.
Okay, yeah.
Ma'am, when you use the formula negative b over 2a, you only get 1 answer.
Yes, because that's for the turning point. So you should only get 1. Yeah. Yeah. Okay, I'm going to add on the side here. Or multiply brackets out and factorize. Yes.
Times the bracket out and then move the 2 over.
Yes. Yeah, but you must just keep the negative half in front of your multiplied out bracket. Yes, you can do that. But then you're going to have to move the thing back so that you can factorize again. So guys, if you did try to multiply out and factorize and you didn't get the same answers, then you must come show me, please, so that I can find your mistake. Okay. All right. Please draw this graph. We have 4 points that we need to plot. We have the turning point, we have the y-intercept, and we have our 2 x-intercepts. Okay, so on your own, quickly, see if you can draw that graph. Yeah. As far as possible, yes. Oh, guys, I forgot to talk about one thing in this equation. Sorry. The a value. We forgot to speak about that. What is our a value in this case? It is negative a half, right? But the sign of the a value is important because if a is negative, that means that the graph is going to look like that. Okay, sorry, I forgot to mention that. That can help you with the actual drawing of it. If you've drawn a whole bunch of points, but you're not quite seeing how they must connect to each other, then look at your A value because that will tell you what the shape of your graph should look like. Yeah.
Ma'am, can you not just look at the y-intercept because it's negative?
Yeah. But you can also have a negative one and then it goes up. Yeah. And once you've drawn your graph, please remember to plot your points. That's very important. Or sorry, not plot, obviously. Label them, I mean. So write the coordinates next to them, please. Otherwise, you won't get any marks.
No, next to all the points.
Yeah, all the points that you've plotted, yes. Okay, I'm going to show you mine. If you're still busy, that's fine. But that is what my graph looks like. So you can see it's a downwards facing parabola. So it's going down. You have your turning point, your 2x intercept, and your y intercept. Now guys, my iPad does it makes it smooth for me. So please don't think I drew it that nicely on my own. It's going to take some practice, right, for you to actually get it. And I don't know, I find the ones that are downwards facing more difficult to draw. So literally turn your page if that's the same for you, right? Just kind of draw them. Something that you must look out for in terms of shape, and there will always be a shape mark for this, is that your parabola can't be too pointy over here, right? So try to not make it look like it's a point and it's a point going down, right? Try to kind of draw it so that it's round, especially at your turning point, because that is what's happening at the turning point, right? It's turning its direction. So it needs to look like that on the picture as well. But again, it's going to take some practice. Don't worry if you're struggling a little bit with the shape. We are going to do more of them. So then hopefully by the end of that, you should be fine with drawing them. Okay, I just quickly want to discuss a few things about this graph that we are going to have to be able to apply to other graphs. Did you talk about an axis of symmetry yesterday? Yes? Some people saying no, some saying yes. I'm just going to add it in here, guys. The axis of symmetry of a parabola is always, let me move that, that's not really where it should be, is always a vertical line. You get the idea. Just put in a dotted line there. A vertical line that goes through the turning point, right? So the pink line that I've drawn there is the axis of symmetry. I'm going to abbreviate it as AOS, like that. So for a parabola, it's always a vertical line. And when I say vertical, I mean that it is perfectly vertical, right? It's basically parallel to the y-axis. So it has the same gradient as the y-axis, right? It's perfectly vertical. So it's a vertical line going through the turning point always. And guys, what that means, and you can keep this in mind when you're drawing it as well, is if you were to fold your page on this dotted line, right? So you folded your page on the dotted line. The two halves of your parabola should be like perfect mirror images, right? The two halves should fit on each other perfectly. It's fine if it doesn't, right? If your one side looks a little bit different to the other one, but that's the idea. Okay, so that is an axis of symmetry. But guys, they might ask you for the equation of the axis of symmetry. So you need to please write this down. The equation, because it's a vertical line, do we see that it's cutting through the x-axis only? Right? It's a vertical line. It's never going to go skew. It's never going to cut through the y-axis. It only cuts through the x-axis at which x value? What is the x value of this point over here? 4. Alright, so the equation of this line is going to be x equals 4. And that will always be the case. It will always be x equal to the x value of your turning point. Where do I get the x value of the turning point from in this equation? It's over there, isn't it? It's P. Yes? So the axis of symmetry is always going to be x equals P. If they've given you the equation in turning point form, you can actually see that straight away. Guys, if they've given you the graph, the equation of the graph in standard form, how do you get this x value? What's the formula? The formula to get the x value of the turning point, if it's given in standard form. Minus b over 2a. Alright, so if it's in turning point form, you're going to get that x value by looking at the equation. It's the value in the brackets. If it's in standard form, which is what you did yesterday, you're going to get it by saying negative b over 2a. Alright, let's quickly write down the domain and range of this graph as well, because that is also something that you need to know. Domain is all the x values, yes? So all the x values, not that we have on our specific, or on our graph that we drew specifically, but which x values could you potentially have on this graph? Now guys, for the x values, we're going to look along the x-axis, right? What is the smallest x value that this graph could potentially have? Do we see this arrow? What does this arrow mean? It's going to continue going further and further, not like that, that's a bit extreme, but it's going to continue going out further and further and further, right? Is there going to be an ending point for that? No, it's going to go to negative infinity, right? On the other side, guys, to get the biggest value of x, this shape is going to continue forever and ever and ever. Sorry, that's not the right shape, but you get what I'm trying to show you. It's going to go to positive infinity, right, along the x-axis. So guys, the domain for this, the quickest way of writing it, the shortest way, would be to say that x is an element of real numbers. Or you can write it as x is an element of negative infinity to positive infinity. That's also fine. But XER is the quickest way of writing it. Okay, just x can be any real number, all the way from negative infinity to positive infinity. Okay, you only have to write one of those ways of writing it. So you can choose the one that you prefer. Now when it comes to the range, it's slightly different. Remember, the range is the set of all y values that you can have on this graph. Now guys, if we're looking at this graph, just to yourself, just check, does this graph have a minimum y value or does it have a maximum y value? Do we agree that it has a maximum y value, right? The turning point is what we look at to get that. The graph can't go, in this case, because it's a downwards facing graph, it can't go higher than the turning point. It's not going to do this and go back up. That's not a parabola, right? So the maximum value of this graph is going to be, what is the y value of that turning point? 2. So that is the maximum value. That's also something they can ask you guys, by the way. What is the maximum value of this graph? Then you're going to say y equals 2. We can write that down just now. But that means that this graph, y values, it's going to have all the y values below 2. Equal to 2 as well. Do you agree? We have a point at 2, right? So we're going to include 2, but then everything below 2. Everything smaller than 2. Okay, so for this you're going to say y is smaller than or equal to 2. Because the graph is underneath, below y equals 2, right? So this graph is only going to have y values 2 and then smaller than 2. Okay, if you want to, it's not essential, you can add that is real numbers. All real numbers smaller than or equal to 2, but it's also fine if you just write that. And then guys, if you want to, of course, you can use the other notation, interval notation. You can say y is an element of negative infinity to 2, but this requires some thinking, because now you must remember negative infinity is the smallest value. You have to have a round bracket for that, and then 2 would be the biggest value. You have to have a square bracket for that. I'm just going to add, I'm just trying to think of potential questions that they could ask. The maximum value of this graph. You have to say y equals 2. Guys, if they're asking for the maximum or the minimum value, you have to always say y equals. You can't just say 2. Okay, it's very important. The y has to be there. Okay, happy? I quickly want you guys to draw one on your own. One like this, a turning point form. Let me actually just move that to the side a little bit so that I can keep these things there. All right, quickly draw that one on your own, please.